My name is Melanie. I'm here to talk about teaching troubleshooting through Modesty and anti-pattern analysis, which is a fun way of saying I'm going to teach you some anti-patterns today. On Twitter, you can find me at MelanieMJ. My name comes up as DevOps and Cake Pops because I love both those things. I don't make cake pops, but I really love to eat them. And use your hashtag DevOpsDaysPhx. So my role today, presently, is that I'm a senior systems reliability engineer for a company called Yardi Systems. Oh, look. Somebody forgot to turn off HipChat. I'm a senior systems reliability engineer at Yardi, and I have to say that these are my opinions, and they don't reflect the opinions of my company. Yardi is a property management software company based out of Santa Barbara, California. We have over 5,000 employees worldwide, and we host 18,000 virtual machines at multiple data centers throughout the world. Okay. We are responsible for monitoring and alerting on systems and a bunch of other fun stuff. But today I'm going to talk a little bit about how we deal with complex systems and teaching people to work with complex systems. So everybody here, raise your hand if you have a complex system. Yeah, maybe. Do you have a chaotic system? There's a sense-making framework called Cynefin. And in Cynefin, the complex domain represents the unknown unknowns. Cause and effect can only be deduced in retrospect. And I'm sure that you've all experienced something like this where something goes wrong and you're trying to figure out what went wrong and you can only tell after. And that's some of the way that we have to deal with problems. So how did we get into this space? How did I get into this space? Several years ago, in the early 2000s, when I graduated college, I was a developer. And I loved software development, and I was a UI developer. And then I moved into a company where we started to use agile practices, and it was super cool. And I was like, wow, we're going so fast. We're releasing like every 3 weeks instead of once a year. And it was so fun. And then I was like, why is it so hard to get hardware? The hardware is so slow. Who's ordering this stuff? And why don't they know? Because we were telling them we were going to release in 2 weeks, and they hadn't procured hardware yet. And when I say they, I really mean us, because we were a company, right? And so at that point in time, I joined the systems administration team, and I became a mail administrator, because that's what they needed at the time. And I learned all kinds of fun stuff about how deploying hardware really was hard, because we had to order it. And they needed more lead time than we were giving them. But also at that time, we were starting to adopt virtualization and pre-containers, when we actually got like virtual machines that we could roll them back, and it was super cool. And I was like, who is doing this? What is this called? How can I find out about more people who do this thing? And so I was searching agile systems administration and agile operations. And then lo and behold, I fell upon the DevOps. Everybody wanted DevOps, and now we're mainstream. Look at all these conferences, it's super awesome. And then I became in love with monitoring, because I realized that I wanted to go back to where I was before, to tactical feedback, to immediate response, and monitoring gives that to you through data analytics. So I know a lot of stuff, and I knew a lot of stuff and things, and I was working with people, and I was always piled on these issues because I could solve problems. And so I was like this kind of weird hero where I was like always busy, always all the responsibility. In the earlier talk today, there was an example of a Venn diagram that was purple, because if it was like, what were you responsible for, and what are all the systems? That was me. It's this like big fat Venn diagram. Like, yes, I am everything. Wait, I can't get any sleep. So I started down this path of how to teach people how to troubleshoot. And I think that at the time, I had no idea what I was doing. I had no idea why I was able to solve problems. I just cared a lot, and that was enough. But really, it's not. So I landed on this research and this one particular piece of literature written by a man named Brendan Gregg. Brendan Gregg changed my life. Hashtag DevOps to Brendan Gregg to wait. There's actually methods. There's methods to solve performance issues. Now, in the talk, I said patterns, and I'm going to use patterns and methods interchangeably, and that may not be syntactically correct, and I apologize for that. So Brendan Gregg has on his blog a whole section about methodologies that can be used for performance analysis. But what I've done in my practice is I've extracted the information that makes sense for when you're doing basic troubleshooting and analysis. And at that moment, I realized there are patterns, there are methods, there are good practices, and I looked at what he had in his literature and realized that I was actually using some of those practices. But what I was also doing was using some of the anti-methods or anti-practices that he had pointed out. And that's what we're going to talk about first. So, and this is the very question that somebody said to me last night. Wait, so you're going to talk about how to tell people what they're doing wrong and make them uncomfortable? And to that, I say, not really, because it's more about observing how people are solving problems and helping them correct that and making it work in a better way. And also, I also think that you need to get uncomfortable before you get comfortable. And then that allows you to realize what maybe you could be improving, right? So the first anti-method I want to talk about is called Streetlight. And I love this anti-method because it comes with a cute little parable about a man who's drunk. Or maybe a woman, but whatever. In the parable that Brendan presents, a person is drunk and he's lost his keys and he's standing under a street light. And the police officer comes up to him and he says, "Sir, what are you doing?" He says, "I've lost my keys." And he says, "Oh, is this where you lost them?" And he said, "No, but this is where the light is best." And Streetlight anti-methodology is just that. And we've seen talking about dashboards. Early in Charity's talk, she talked about how all the information may not be on the dashboard, and that isn't anti-pattern. You have a dashboard, you've got some information or some place where you know to look because you have information in that system or analytics or metrics, and it is an anti-method because it's not allowing you to look outside that area. So the other one, which is not about the drunk man under the streetlight, but just a drunk person in general, where you tune things at random until the problem goes away. So it's like, yeah, just choose something, change it, choose something else, change it. It's not a pattern. Another one which is similar to that, but used as benchmarking in Brendan's documentation, is called random change anti-method. In this case, you would choose something that's tunable, like CPU additions or RAM additions, or maybe a faster disk. And the process is like measure a baseline, pick a random attribute to change it in a direction, measure a baseline, change it another direction, and then go back to the beginning and change it again. Cool. Another one is the traffic light methodology, which is kind of similar to, or anti-methodology rather, which is kind of similar to the streetlight, except in this case, it's all about your dashboards. This is one of the dashboards that I designed for one of our major systems, and I've highlighted an area here. So this pink section with the nice rounded corners was here. This was not. We had a major outage, and everything on this dashboard looked exactly the same as it does right now, except this wasn't here. And everything was down. So it was green. The street light said it was green, and people were like, "Melanie, why is the system down?" Because the dashboard's green. And these two little nice dialy dupes, I like to call them, they were added because this is a time series graph. And so you can't tell what's normal if you're looking at the last hour, and these have thresholds on them. And I get it. You know, this is an alarm. This is a system. It may not always represent what's broken, but that's the truth of the streetlight anti-method, is that you won't always know what's broken, and not everything will be on your dashboard. Cool. Now we're going to talk about things that might make you more uncomfortable. The first one is the blame someone or something else anti-method. And 4 very simple steps. Find a system or environment component that you are not responsible for. Hypothesize that the issue is with that component. Redirect the issue to that team. And then when you're proven wrong, go back to the beginning. I like to also call this Not my problem. I'm too busy for this. I don't know enough about that system, so I'll give it to somebody else. Or it's the network. Cool. So that's the end of the information I have from Brendan's anti-methods and the start of a few that I've come up on my own, I think that root cause is an anti-methodology. And I'm sorry about people who provide their clients with RCAs, including us. Because I don't think that if you think that there's one single area of your system that causes a problem, that you're not going to be going around pointing a finger at other people. If you see your system as a collective and your company as a collective, then you will realize that there are major cause contributors and minor cause contributors to every failure and every issue that you experience. Yes, there could be one thing that was really, really bad, but the systems are way too big, and the problems that we handle are really complicated. So root cause is just another way to not look in multiple directions at once, but just look at one thing. So we've tried to replace this nomenclature in our teams with cause contributor, and that's helped a little bit. We are still working on it. The other one I have is called just restart thing, or just restart it, because it's really common for us to do that, and it is a radical change. Another one that I came up with recently is like to call out of control, where you don't have a control or comparative or a known good state for a system. And there is an actual methodology that Brendan employs that is on his documentation called problem statement. And I think out of control is a form of anti-method where you haven't written a problem statement and you don't really know what the problem is or what the known good state of the system is. But I really just like to run around and say, this investigation is out of control. Cool. Superstition or generalized response. So yesterday in a meeting, we were talking about how we were introducing cache to a certain area of our system. And our QA developers, or QA team, are QAing problems, and they're reporting those issues to us, and they're saying, oh, this thing doesn't render correctly when cache is on, so we turn all the cache off. And they're like, the thing still doesn't render directly, I don't trust you, the cache is broken. And what I was pointing out to my team was like, look, we need to make a trust relationship in this scenario, because if we don't fix this right now, everybody's always going to think that the cache is solving the problem. And that's a form of superstition or generalized response. So one of the generalized responses you might use is just restart it. Or that thing that broke last year, just like that, I know it's that thing, right? And that is just a form of not looking outside of your regular experience. So how do you know? How do you know what you're doing is an anti-method? First of all, I want to admit that I use anti-methods all the time. I have a script in one of my Nagios installations that checks as another Nagios installation and has to restart Nagios every time we set a maintenance window. So I'm admitting that I'm using an anti-pattern. But the truth is that I don't have enough time to solve that problem. So you might be doing something a lot, repeating that thing over and over again and not getting the same results. Somebody told me that's the definition of crazy. You might really just feeling frustrated, or you haven't gotten to the root, or I just said root, you haven't gotten to the major cause contributor of that particular problem that you're dealing with. That will get you really frustrated. Or you're not using enough time, or you're using too much time. All right, so in our reality, the thing that you are responsible for is down, and you restart it. It works again, and that might be your job. And I'm not here to tell you you have to stop doing that. What I'm here is to tell you how to maybe work towards not doing that in the future. So let's talk about the who. Who uses anti-patterns? You might have lack of experience with a system or lack of experience in general. You might just need some training. You may need a mentor or somebody else to work with, or you might need some real context around the system that you're working with. You could be in a blame or poor culture. one of the reasons you may not be afforded time to solve a problem is because if you don't solve that problem in a short amount of time, then somebody's going to blame you for how long it was broken, right? And that is really, really hard to deal with. You might be isolated from the teams that wrote the code, or you might be isolated from the goal of the sales people who wanted the code deployed in the first place. And you may be isolated in a silo manner, where we're talking about different teams that have to work together, except they're not really interconnecting or communicating with each other. You might just be busy. Or you could be completely disconnected or disengaged from your job, in which case most people around here are hiring, including us, so come see me. So busy. I want to talk about busy, and I want to talk shortly about heroes. Heroes are too busy to teach you, and they can or may ruin your culture. And I think I used to be a bit of a hero before I understood methodologies and patterns, because I really enjoyed that rush of like, oh, Melanie will fix it, right? Except then I was really stressed out, and I wasn't able to help other people. And heroes are built from broken reward systems. They don't have time to teach you how to solve problems because they're busy. Sometimes they don't know actually how they solve problems, like I used to be. And in really rare cases, there are some asshats out there that will make conditions to fail so that they can solve them simply because they will be rewarded for it. And if you've never seen that before, I'm really happy for you, but I have. And when we reinforce individual heroics, we reinforce that constant break-fix pattern. It's really unhealthy for our culture. I think it's a form of social normalization of deviance. And I would encourage you to look a little bit into this, but I'm just going to give you a taste of it. The social normalization of deviance is that people within the organization become so much accustomed to a deviant behavior that they don't consider it as deviant, despite the fact that they far exceed their own rules for elementary safety. And we're not talking about human safety. We're talking about system safety. So our altered perception of normal creates excuses when we use anti-patterns for problem solving and analysis, and allows us to continue in this pattern of doing things that aren't really helpful to the company or the product. So what can you do? You have to come up with a way that you can get out of this pattern, or teach people how to get out of these patterns. So one of the most important things is your retrospective, an evaluation of an outage, maybe a blameless postmortem. You could create a diagram. You could ask questions about available data, like what data is available? Is there more data that I can use to solve problems? Plan an approach for next time if you think there will be a next time, unless you think it's a one-off, or maybe you just create an alert monitoring. Write a problem statement, so that is an actual method. Examine possible methods that you might use, or update your heuristics. And heuristics are known good practices. And I learned about heuristics from a talk that was given by an engineer at Twitter named Ramin. And his Twitter handle is here. It's called How I Learned to Change My Mind to Become a Better Engineer. And in that same talk, he talked about bounded rationality in decision making. Bounded rationality is the idea in decision making where rationality of individuals is limited by the information they have, the cognition limitations of their minds, and the finite amount of time that they have to make a decision. And you can increase your bounds of rationality through experience, through getting more data, through improving your cognition of a system. And so if that means diagramming or working with other people, learning about it, that's something you could do. Or time. Sometimes you just need more time. Okay, so the people stuff. Empathy and modesty. In teaching other people, I have had to change the way that I approach problem solving and realize that people think differently. I know this seems like really simple, but as a young engineer, I thought everybody was just like me. And in truth, everybody is different. Don't work in isolation. The context that you need to understand how developers work or how the QA people really need to send all that email, It really helps you to understand the affected parties. So if we don't do this testing this way, then who will be affected, and how will they be affected, and why are they affected when they don't get what they need from the systems being available? And also, I really encourage you not to hide information. I know there are legal reasons to hide information, but within your organization, there are no really good reasons to hide information. So we try to share as much as we can. Under the Modesty blanket, I don't walk in and tell my students, you're going to be awesome, you're going to teach this class, you're going to be better than me, but I have an expectation that I'm going to learn something from every single person in the room because they know something that I don't, and that might not be about solving the problem, but it might be about that Joe worked on that product 10 years ago, and if I really need to know something about that, I need to talk to Joe. But at some point, some of your students will excel beyond you. I have a lot of students who build dashboards within our dashboarding system that blow the pants off of mine, and I'm super proud of those ones. Accept new ideas. Always, be open to learning something from other people, and then always be learning yourself. I think expertise is overrated. Cool, so we have a little bit of time. I'm going to cover a few of the overview of the methodologies that Brendan Gregg has on his blog. Drill down analysis is what I had been doing. I had been looking at things from the top, examining the next level details, picking interesting breakdowns, and if that didn't work, going back to the top. And a really simple version of this is if you host a web application that is not a mesh, but is behind a firewall, a load balancer, and has a web server and a database server, then each one of those is a layer. And if you can think about them from the top down or from the outside in, then you can start to peel away those layers and work on each one of them individually. US Air Force, and it was popularized in technology by Roy Rappaport a couple of years ago at Monitorama and around that time. And it really is just, you can look at it in Wikipedia or whatever, but you do an observation, you think about how you're going to orient yourself based on that observation, you decide what you're going to do, and then you act. And then finally, the use method, which stands for utilization, saturation, and errors. And this is the one when I went to Brendan Gregg's blog and I realized that I was doing drill down, I started to apply use in a lot of other areas because it made me faster. So instead of seeing things in multiple layers, I could take each area of the system and say, how many errors are there? What's the utilization? Is it saturated? Is it going over a certain level? And that was helpful for me. So in sum, I want you to seek to replace anti-methods and patterns. I'm not saying you have to stop. I just want you to get better. Expand your bounds of rationality. Learn new things, new methods. There's a couple of cool things that Ramin talks about in that where he does things like relearning, where he revisits something that he did 5 years ago, 6 years ago, and asks himself, how would I solve that problem today? What has changed? Have I learned anything? And another way of saying, like, do you have 10 years of 1 year of experience, or do you have 10 years of experience? And also, model modesty and learn from your peers, your mentors, and your students. And finally, this is my cube. The little sign there says, we'll train for freedom. Because that's what I want. I want everybody to just keep learning at work. So, and I'll have lots of references. I can post them up. So, thank you. I think I have time for 1 or 2 questions. Yes?
1 or 2 questions?
Yes.
Okay, so what would be, or do you have any examples of, deviant behavior that you've seen normalized in the workplace?
Yes. The question was, have I seen deviant behavior in my workplace? I have to be careful because this is getting recorded. What I want you to think about it, not in terms of people, but in terms of systems, right? And the idea is that the behavior isn't necessarily something that you're doing on purpose. It's that you've learned to do it. And a really simple one, if you understand session state in Microsoft applications, like we have multiple people attached to the same web server, and on that web server you can have multiple sessions. And we have some indicators that will tell us if we have a lot of requests that are stacked up trying to get processed. And in some of those cases, it will be one session that is affected, but there could be 50 active sessions on the web server. And one of the normalized deviant behaviors that we have is that we will reset an application server to solve a problem. And that's not hurting anybody, but we just destroyed the sessions of 49 individuals to fix one, right? And that's one of the things that I think fits into it.
Do we have time for one more question?
Okay, good, great.